Welcome back to the Learning Studio. You're watching our mathematics series, and today we're starting a brand new section, Cryptography, Security, and Emerging Fields. This is where ancient mathematical ideas meet modern technology to protect data, secure communication, and power digital innovation. If this is your first time here, don't forget to follow us by clicking the link below, and the full playlist is in the description, so you can explore every episode in order. Our first stop in this section is one of the most beautiful and mysterious branches of mathematics, number theory. Imagine this. Thousands of years ago, mathematicians studied prime numbers for no practical reason. They seemed like puzzles, the indivisible building blocks of the number system. Fast forward to today, those same primes are protecting your bank account, your private messages, and even the blockchain technologies reshaping our world. Number theory is proof that what once seemed purely abstract can become the foundation of our digital security. Here are the key ideas. Prime numbers, the atoms of mathematics. They can't be broken down, and yet they're the key to encryption systems like RSA. Modular arithmetic. Think of it as clock arithmetic. After 12 comes 1 again. This simple idea is the backbone of modern cryptography. Cryptography. Secure communication is built on problems from number theory, like factoring large numbers or computing discrete logarithms, problems that are easy to state but incredibly hard to solve. Blockchain. From Bitcoin to Ethereum, blockchain technologies rely on number-theoretic algorithms to secure transactions, verify identities, and prevent fraud. Prime-based algorithms. From hashing functions to digital signatures, primes keep digital systems safe from attack. Why it matters in AI, security, and technology. Number theory isn't just an ancient curiosity, it's one of the most practical mathematical fields today. In cybersecurity, it protects data, emails, and financial systems. In blockchain, it ensures trust in a decentralized world. In coding theory, it helps detect and correct errors in data transmission. And in the future, post-quantum cryptography will rely on new number-theoretic techniques to secure information against quantum computers. It's the invisible shield that keeps our digital world safe. So, number theory shows us how ancient puzzles about primes have become the guardians of modern life, turning pure curiosity into the mathematics of trust and security. In our next episode, we'll dive deeper into abstract algebra, groups, rings, and fields. These structures extend number theory into powerful systems that not only shape cryptography, but also error correction, coding theory, and even modern physics. Don't forget to follow us by clicking the link below and check out the full playlist in the description. Each episode in this section will bring you closer to seeing how mathematics safeguards the digital era and builds the future of secure technologies.